All right, so in this question, we're given our original function f of x equals to square root of x, and then we're given some transform functions, and we need to find the domain and range of these transform functions. So in order to do this, you want to know how to sketch out your functions and then do your domain and range based on that. Now let's just talk about the parent function f of x of the original function. We know a root function starts at the origin and it just goes like this. So I know my domain is all real numbers such that x is greater than or equal to 0. And I know that my range is all real numbers such that my y is greater than or equal to 0 because your minimum x value and y value are both 0. So based off this, you can just transform your functions and then do the domain and range of the transform functions. So let's start with the first one over here. This transformation is just 2 units to the right. So my function is just going to look like this because from the origin, I've just transferred the point 2 units to the right. So my domain is going to change now as all real numbers such that x is greater than or equal to positive 2. My range has not changed because my minimum y value is still 0, so y is just greater than or equal to 0. Let's go to the next one over here. In this one, a vertical stretch or compression will not affect your domain or range at all. So you don't have to worry about this. Same with horizontal stretches and compressions. You only have to look for reflections and put the reflections in your sketches, but vertical stretches, compressions don't affect your domain and range at all. So this shifted 1 unit to the right and 4 units up. So 1 unit to the right, 4 units up, and there's no reflections. So that's what my graph looks like. Again, my domain and range will be slightly different now. My domain is all real numbers such that it's greater than or equal to positive 1. And my range is all real numbers such that it's greater than or equal to positive 4 because now 4 is my minimum y value. Same idea for these questions here, but now I have a reflection in the y-axis. If the negative is inside, it's a reflection on the y-axis. If the negative is outside, it's a reflection in the x-axis. So this graph is not shifted left or right at all, but it is shifted up by 1 unit. So my starting point moves from the origin up here. And normally it will go like this, but since it's reflected in the y-axis, it's going to look like this. So my domain for this function is all real numbers, but now my highest x value is 0, which means that my domain is going to be x is less than equal to 0. So the reflection in the y-axis has switched the sign over here of the inequality. My range, my lowest value is positive 1, so it's all real numbers such that y is greater than equal to positive 1. And then this last one over here, again, we have no reflections. We have a vertical stretch, horizontal compression that doesn't really matter. It's not going to affect our domain and range. This is shifted 5 units to the right and 3 units down. 5 to the right, 3 units down. There's no reflections. My domain is all real numbers such that x is greater than or equal to 5. And my range is all real numbers such that it's greater than or equal to 3.